Hey guys, welcome to another video, and today we're looking at mole concept, right? So mole concept is something that students normally find difficult, right? So I'll try my best to see how I can get this a little bit easier for you to understand. So let's go. So the mole is the amount of a substance that contains 6 times 10 to the 23 particles, right? So that's what a mole is. So the mole has that amount of particles present in any substance, right? So the substance can be a solid, liquid, gas, it doesn't matter, right? Now we look at terms that we need to know. So the molar mass is the mass of 1 mole of any substance, right? So once you have 1 mole of a substance, then the mass that it contains, it's called the molar mass, which is measured in a unit of gram per mole, right? We look at this number, the 6 times 23 times 10 to the 23, which is known as Avogadro's number, right? And we look at the relative atomic mass, which is noted as A, capital AR, is the ratio of the mass of one atom of an element compared to 1/12 the mass of carbon 12, right? So all the masses on your periodic table, they are relative atomic masses because they are compared to the mass of carbon 12, right? So that is what relative atomic mass. It doesn't have a unit, right? So anything that's relative doesn't have a unit, right? So calculations of molar mass, right? So if we have a substance here, sulfuric acid, right, H2SO4, to find the molar mass, which is the amount of mass in 1 mole, right? So we just have one H2SO4, so it's 1 mole of sulfuric acid. So it's the amount of hydrogen there, which is 2, times the mass of hydrogen, which we take from our periodic table, which is 1, plus the amount of sulfur there, which is 1, times the mass of sulfur in the periodic table, which is 32, plus the amount of oxygen, which is 4, times the mass of oxygen, which is 16. So when we do that, we get 98, and remember it's in a unit of gram per mole, right? Next one, we have aluminum sulfate, right? So we know that aluminum is 2, right? So 2 aluminum here, so we have 2, and the mass of aluminum is 27, so 2 times 27, plus we have the bracket here with 3 out, so that means whatever is inside the bracket is multiplied by 3. So we have 1s multiplied by 3, so we get 3 s's, and the mass of s is 32, right? Plus we have 4 o's here, and we multiply that 4 by 3, so 4 times 3, and the mass of o is 60, right? So we get it to be 342 gram per mole. So finding the molar mass is the same process for any specific compound, right? So let's look at some equations that we're going to use while doing calculations for finding the mole of substances. So mole is equal to the mass in grams. So you have to ensure that the mass of the substance you have is in grams over the molar mass, which we just found, right? Same process we'll use, right? Or we can find it's the amount of atoms or molecules or electrons, right? So any of those that you have, so if you have the amount of molecules present in a substance, we divide it by Avogadro's number, which is 6 times 10 to the 23, and we get the amount of moles, right? And we have mole is equal to volume of gas over volume at RTP and STP. So this equation only used for gases, right? So if it's not a gas, we're not able to use this equation to find the amount of moles, right? So the RTP and STP are different conditions on which gases exist, right? So RTP means at room temperature and pressure, and STP means standard temperature and pressure. So at STP, the volume of any gas, right, is a constant, which is 22.4 dm3 or 22,400 centimeter cube. And for RTP, for any gas, 1 mole is occupies a volume of 24 dm cube or 24,000 cm cube, right? Now, the concentration of any solution is the mass of the solute dissolved in 1 dm cube or 1000 cm cube of a solution, right? So when you talk about the concentration of solutions, it's basically saying how much mass of a solute is able to be dissolved in 1 dm cube of a solution, right? Now, the concentration can be measured in a unit of gram per dm cube or mole per dm cube, right? And later on, I'll show you how you can look at the unit to actually tell you what the equation you can generate from it, right? So the number of moles per dm cube of a solution is also called molarity. So the concentration of a solution is also known as molarity, and that symbol is normally a capital M, right? So concentration now, let's look at the equation. So remember, it can be measured in gram per dm cube. So gram, we know, is the unit of mass, right? And dm cube is the unit of volume. So therefore, we have the mass of the solute, right? And remember, the solute is the substance that is being dissolved in a solution, right? So it's the mass of the thing that is being dissolved over the volume of the entire solution that is created, right? So that's how we get the mass, gram, dm cube, volume, right? It also can be calculated as your mole, which is a unit of mole, right? And volume, unit of dm cube. So mole per dm cube means that it's mole divided by volume. So it's the mole of the substance over the volume of your solution, right? And then we look at the molar concentration. So the molar concentration is calculated by finding mass concentration, which we see is in gram per dm cube, which is basically just the concentration of the substance over the molar mass. And we know how to find molar mass as well, right? So now we're going to put all this into practice with some questions. All right, so let's go with this question. So we have 0.05 mole of copper carbonate were heated. Calculate the mass of copper oxide formed and the volume of carbon dioxide formed at STP. All right, so the first thing, once we're given a question that requires a chemical equation, the first thing before doing any calculation is to write our chemical equation, right? So once copper carbonate is heated, then that means this is decomposition, right? So we only have copper carbonate on our reactant side. It's now broken up into copper oxide and carbon dioxide. All right, so that's our chemical equation. Now, secondly, we need to ensure that the equation is balanced, right? So we check copper, one copper, right? 1C, 1 carbon, right? And 3 oxygen, 3 oxygen. So from this equation, we know something very important, that requires 1 mole of copper carbonate to give us 1 mole of copper oxide and 1 mole of carbon dioxide, right? So that is going to be important in calculating our unknown values, right? So let's go. So the first part says, what's the mass of copper oxide, right? Well, we know that we didn't got copper oxide. We got the mole of copper carbonate. Now, since we got mole of copper carbonate, right? And because we got the compound, we know the molar mass, then we can use the equation that says mole is equal to mass over molar mass, right? Now, a next thing to note is, because it says 1 mole of copper carbonate from our equation gives us 1 mole of copper oxide, that is our general equation. But for this experiment that was done, instead of 1 mole of copper carbonate, it was 0.05 mole. So therefore, we can make the link that we require 1 mole, so copper carbonate to copper oxide is 1:1 ratio, right? But this was not that was done in the experiment. What was done is that 0.05 mole of copper carbonate So therefore, if it's a 1-to-1 ratio, if we had 0.05 mole of copper carbonate, then we would have produced 0.05 mole of copper oxide as well, right? You got that, right? So since we know now that the mole of copper oxide in this question is 0.05 mole, then we can find the mass using this equation, right? So mass will be molar mass times mole. So the mass would be molar mass times mole, right? So let's call this mm, right? So the mole is 0.05, and to find the molar mass of copper oxide, right, it would be 80, right? So the molar mass of copper oxide is 80 because copper has a mass of 64 and oxygen is 60. So we get 80 here, right? So when we multiply those two numbers, we get 4 grams, right? So the mass of the copper oxide that was produced from heating copper carbonate would be 4 grams, right? Let's look at the second part. Now it says carbon dioxide we know is a gas, so we're finding the volume of the gas produced at STP. So this part is important, right? So without this part, we're not able to complete the question. So we know at STP, right, the volume of 1 mole of any substance is 22.4 dm cube, right? So that is a standard that we know, right? So remember the equation would be mole is equal to volume over volume at STP this case, right? So we're finding volume, so it would be volume would be equal to mole times STP value, right? And so now we need to know what the mole of carbon dioxide is. So remember again, we noticed that it's a 1-to-1 ratio for everything. And we just found out because in this case, it's not 1 mole, but it's 0.05 mole, right? So if it's 0.05 mole here, then it's 0.05 mole here, and also 0.05 mole there. So that means the mole of carbon dioxide is 0.05 mole, right? And the STP volume is 22.4 dm cube. So we have a volume of 1.12 dm cube of carbon dioxide produced, right? And if you ask to change it to centimeter cube, we just multiply it by 1,000 and we get 1120 centimeter cube. All right, so see, it's not that hard, right? So let's try another one with some more use of other equations. All right, guys, so our next question is a solution of sulfuric acid has a concentration of 0.25 mole per dm cube. Calculate concentration of the solution in gram per dm cube and the mass of the acid contained in 250 cm cube of solution, right? So we should note here that we have the acid, right, and it gives us our molarity or our molar concentration to be 0.5 mole per dm cube. So what this value tells us is that for every 0.25, for every 1 dm cube of the acid, there is 0.25 mole, right? So with that, we need to find our mass concentration, right? Because this is gram per dm cube, so we're finding the mass concentration, right? And we're given the mole concentration. So for one, we can find what's the mass of the acid in this concentration here, right? So first, we know that mass is our mole times molar mass, right? Given from mole equals to mass over molar mass, right? So therefore, mass would be mole times molar mass. So the mole, again, right, is 0.25 multiplied by your molar mass, right? We just did the molar mass of sulfuric acid, which is 98, right? So we multiply, we get 24.5 grams, right? So now we have the mass of the acid. So we want to find the mass concentration, which is the mass of the acid, over the volume, right? So we have 24.5 grams of sulfuric acid in 1 dm cube, because remember it's 0.25 mole that's in 1 dm cube, right? So we use the 0.25 mole to find the amount of grams in it, right? So this gram is in 1 dm cube, right? So therefore the mass concentration will be the 24.5 gram now per dm cube, because we have mass over volume, right? And then second part is our mass of the acid, that's in 250 cm cube of the solution. So we know that from the mass concentration we can find the mass, right? Because we're just now given the mass, right? So we have the mass concentration, right? And we have the volume that's given in the question, right? So therefore the mass would be mass concentration times volume, and the mass concentration is 24.5. The volume, because this is in centimeter cube but your mass concentration is in dm cube, we have to convert this to dm cube, which is divided by 1,000. So we get 0.250, and then we multiply, we get 6.125 grams, right? And that would be the amount of mass of the acid in the 250 solution, all right? So going to try one more, and then that's it for today, all right? All right, guys, so our final question is, what's the mass of sodium hydroxide that must be added to sulfuric acid to produce 7.1 grams of the salt that will be produced? All right, so again, this is a reaction there, so it's not just one substance, but it's a solution. So we're combining two things, so it's an equation that we would start off with, right? So therefore we have NaOH plus H2SO4 to give, right? So the salt would be sodium sulfate, right? So this is an acid and a base, sodium sulfate, and it would produce also water, right? So remember, we start with our equation. The next part is to ensure the equation is balanced, right? So we have 1 Na here, 2 there, so that means we put a 2 right here. Sorry, not here, on this side, right? So we have 2H here and 2, so that's 4, right? We only have 2 here, so we put a 2 here, right? So we have 2 oxygen here and 4 here, so that's 6. We have 4 and 2, so that's 6. And we have 1s and 1s, so now the equation will be balanced, right? So now after balancing the equation, right? So that means we use 2 moles of sodium hydroxide to react with 1 mole of sulfuric acid to give 1 mole of sodium sulfate and 2 mole of water, all right? So the aim is to find the mass. So we're finding the mass of sodium hydroxide, right? But we're given the mass of the salt, which is 7.9, with 7.1 grams, sorry, right? So because we're given mass, we know that mole is equal to the mass over molar mass. So we need to find the molar mass of the mass that you have, which is the molar mass of sodium sulfate. So it's 2 Na, so that's 23 times 2, plus S, 1S, so it's 1 times 32, plus 4 times 60, right? And that would give us 142 gram per mole. All right, so that is the mass of the molar mass of sodium sulfate. So now we can find the mole, which is the mass, 742, right? And when we do that, we divide, we get 0.05 mole, right? So that is saying instead of the 2 to the 1 to give us 1 and 2 moles, we produced from our experiment, it was produced 0.05 mole. right? So we're going to make the link between what we want to find and what we have found, right? So the relationship, so we go with NaOH to Na2SO4, right? So in the chemical equation, it's a 2-to-1 mole ratio, but in our calculations, the 1 was 0.05 moles instead. So therefore, if we need to find the amount of moles of NaOH, we can just put an X there, right? And then we cross multiply. So basically, X moles of NaOH would be 2 times 0.05, which is 0.1 mole, right? So we have 0.1 mole of NaOH, right? But the aim is to find the mass and not the mole. So again, we'll use this equation, right? So we have the mole and we know the molar mass. So the molar mass of NaOH for Na is 23 plus O, which is 16, plus H, which is 1, right? So that is 24 plus 16, which is 40 grams per mole. So that's our molar mass. So therefore, the mass would be equal to mole times molar mass, which your mole is 0.1 and your molar mass is 40, right? So when we multiply this, we get 4 grams. So what this is saying is we need 4 grams of NaOH to produce 7.1 grams of Na2SO4, right? So guys, this is generally all you do for any mole calculations, right? So the first aim is to know your equations. The second is, know your formulas, right? The second is, once you're given a reaction, you write the chemical equations, ensure it's balanced, and then you use your ratio of your moles, right? And then you apply your formulas, right? Once you do that, you should be able to answer any mole concept question, right? Thank you very much, guys, for watching today, and see you guys next time.